All right, folks, the visiting is good, but somebody's going to get upset if I don't start my session on time. All right, we're going to get going in this for the sake of time here. Another reminder for the dine around, please do sign up for the dine around experience for supper tonight, again at the registration desk. All right, on to our next session. In case you don't know me, my name is Ian Epp. I'm an agronomy specialist with the Canola Council of Canada, and I'm the chair of this session. This session is the 2024 crop updates and report session. We have 7 speakers lined up and 70 minutes. Why we don't want to be too late here. We want to get this going so we have time for a few questions. Speakers, again, a reminder, please do try to keep yourself on time. First up, we have a virtual presentation from David Lee, National Agroclimate Information Service Manager with AAFC, and he's going to give us a 2024 Agroclimate review. This is a virtual presentation.
Thanks, folks. Hopefully you can hear me okay. Okay, good. Thanks. All right. Well, thanks for the opportunity to come speak. My name is David Lee. As was mentioned, I'm the manager of the National Agri-Climate Information Service, NACE, within Agriculture and Agri-Food Canada. Would have loved to have been there today in person, but unfortunately a number of things came together that prevented that from happening. So we'll do this virtually, and hopefully it goes okay. 10 minutes, and I lost to go over. So let me just start by talking a little bit about what NACE is, the National Agri-Climate Information Service. It's a center of excellence within AAFC, Agriculture and Agri-Food Canada, focused on science-based, near real-time monitoring and forecasting Canada's agricultural climate. We play a lead role in monitoring agroclimate conditions across Canada, including drought, excess moisture, and temperature extremes. One of our key products is our drought monitoring product that some of you may be familiar with. And this is a monthly product that we produce looking at drought-like and drought conditions across Canada. And then we work with our North American partners at the US and Mexico to provide this type of information on a continent-wide basis in our North American drought monitor. And so some of this information will come up a little bit later on in my presentation. So when we're looking at the 2024 growing season, this no surprise to anybody in the room, I'm sure, we've got to look back a little bit further because 2023 was a year of low precipitation across much of the prairies. And just as an aside, I am going to focus largely on the prairies. I understand there's canola growing elsewhere in the country, but I think this is probably our majority of canolas growing in the prairies, so the focus of the presentation will be largely on the prairies. As I mentioned, we have low soil moisture going into 2024. April through August, there's not a lot of rain received across the prairies. You can see these areas in red are very low, yellow, below normal amounts of precipitation, and that was through the summer months of 2023. The winter, fall and winter wasn't a lot better. There's certainly areas on the ground northern Alberta that was very low, exceptionally low amounts of precipitation received, and then we've got some areas that got a bit of green, but a lot of that was received kind of as snow late in the early spring, late winter, so didn't really impact soil moisture that much, and so things were not looking great as we headed into growing season 2024. So this is our drought map, and you can see there's a lot of areas here that are identified as being moderately drought, even into severe and exceptional drought around Edmonton, those areas. And so this was as of April 30th. Things were looking kind of rough. So then our spring conditions came along, and luckily we received some rain, and that was great. Most of the areas across the prairies received above normal precipitation in the spring of 2024. The blue areas were exceptionally high. Green areas were around normal. And to combine with that, we kind of had decent temperatures as well. So April was near normal temperatures across the prairies, and then May was a little bit lower than normal, but that was a good thing from a precipitation perspective, I think, because it allowed decreased evaporation to take place, allowing more moisture to sink into the topsoil. So this is contrasting that earlier Canadian drought monitoring map to June. You can see there's not nearly as much areas that were dry across the prairies, and thankfully that's from that rain that we received. As we headed into the summer was pretty decent for the most part, overall anyways, from 90 days up until August 31st. You can see a lot of areas were pretty decent in the green, normal, above normal. No areas that looked excessively bad. But it was kind of a tale of several months, as you guys are likely fairly aware. We had above normal precipitation in June, but July was quite dry. And you can see here this map down in the lower left-hand corner, several areas that received very little moisture. And then as we get into August, we've got some rain again and start to come back. So overall, what impact did that have on our yields? Well, from what we can see through some of our other products that we have that looks at yield monitoring, canola yield in Saskatchewan at least was close to the 5-year average, slightly above 2023. Overall, the yield outlook for canola in 2024 was above average for much of the prairie provinces. That was compared to the last 5 years. So where are we now? Well, we've had a below normal precipitation and above normal temperatures throughout most of the fall in the prairies, resulting in worsening conditions into October. Once again, we're starting to see some abnormally dry areas, creeping into the moderate drought areas. And so at the moment, we've got about 61% of the prairie region classified as abnormally dry or moderate to severe drought, including 57% of the region's agricultural landscape. Going forward, we're looking at a La Nina. So La Nina is predicted to be coming winter this year, and that usually brings colder temperatures across Western Canada. La Nina winters also tend to be above average for snowfall across Western Canada. This map is given to us from our NOAA partners in the US. Looking at what ECCC is bringing to the table as far as winter forecasts for January and February, the map on the left there, we're looking at high probability of above normal precipitation across the prairies, and a high probability of a colder or near normal temperature-wise across the prairies. So what I might also do is just invite you to go to our Drought Watch website, www.agr.gc.ca/drought, and we've got lots of information, lots of various maps there. Those Canadian drought monitor maps are housed there, as well as temperature and precip. Some of our modeling maps are there as well, so lots of other information that may be of interest to you going forward. So, I think I'm within my 10 minutes. I wanted to try to go rather quickly through some of those maps, but I appreciate the opportunity to come here and show you some of the information that we have.
Are there any questions? No questions? All right, as timekeeper, I will take the extra 2 minutes, and I'm sure somebody can use them later. Thanks, David. Next, we'll have Dr. Raju Soolanayakanahally, a research scientist from Agriculture and Agri-Food Canada. His presentation is called From Flames to Fields, Understanding the Impact of Forest Fires on Agriculture. Raju.
Good morning, everyone. Today I will be talking about the impacts of forest fire on field crops. Before I get going, I would like to acknowledge that the Saskatchewan Research and Development Center is located on the Treaty 6 territory and the homeland of Métis. We respect the First Nation ancestors of this place and reaffirm our relationship with one another. In doing so, we would also recognize that many of you are coming from other indigenous land. In doing so, we are actively participating in reconciliation as we navigate our time in learning and supporting each other. When we look at the forest fire events in the recent past, especially 2023 is very unique. The climate of Canada is warming at very rapid pace, especially at high latitudes and in the months of winter and spring. Here I'm showing like the last from 1986 to 2023, the fire events and the number of hectares that got burnt. 2023 we had 15 million hectares that was burnt, and I have divided this map into 3 zones that looks eastern, prairies, the western and the northern regions, and you can see it was everywhere. And altogether, when we look at the overall average across the same years, it used to be generally 2.1 million hectares, but now we reached 15 million hectares. What it happened was like some of the fire events were also very close to communities, and that led to evacuation of people from those communities. Almost 250,000 people were evacuated from close to 300 fire events, and that have long-lasting social and health impacts throughout the country. With changing climate, the ground foliage or the fuel that is available on the Canadian forestry landscape becomes much drier and drier. That leads to a lot of incidences and intense fires that will become more frequent. One of the reasons for that is, here I'm showing all the map of the major forest fires that occurred throughout the Canadian landscape last year. We can see the number of millions of hectares that got burnt in Alberta, Saskatchewan, and Manitoba. Predominantly, most of these are from northern regions. And the fire was also started way early. We had the first fire event in mid-April that was unprecedented in the Canadian fire history, and it lasted all the way into late October. So almost we had the entire spring snow melt to the first snowfall. We had somewhere the forest fire burning across the country. And in this map, I'm showing like some of the areas. For example, in Quebec, we started to have fires starting in June and go all the way up to August. However, when we look here in Saskatchewan, we had early forest fire, then there were reductions, but Ontario and Quebec, British Columbia had major fires. Depending upon the wind events, which direction the wind blew, a lot of that smoke was brought here onto the prairies. And some of the northern forest fire, when the northerly winds came southwards, that brought a lot of smoke and led to smoke blanket on our major field crops. When we look, 2023 was not bad when we look from the number of fire events. We had just 6,700 wildfires compared to the annual average of 8,000 forest fires that we always record. And most of these forest fires, especially in 2023, 4 lightning events caused 30% of the area to be burnt. That means almost 9 million hectares got burnt by 4 lightning events. And again, as I said, these events become more and frequent and intense depending on how dry the fuel source is. And not all fires are created by lightning. This was the fire that my team created at Indian Head. And we were just cleaning along the fence line in early April, and just the chainsaw spark led to almost 30 acres burnt within like less than 10 minutes. And you can see some of my Siberian tree lost genetics got burnt. And I lost a set of like 10 to 12 trees in that one. And these fire events are very expensive. Just to douse this fire, it cost us $35,000. And my director was rich enough to cover for my mistake. Thank her. When these fire events happen, what really occurs in the atmosphere is like, I'm showcasing two graphs here, like the root zone soil moisture dry amount as well as the vapor pressure deficit anomalies compared to the past years. The maximum root zone soil moisture increased in Western Canada in early May. Eventually, this was followed by drying in Eastern Ontario and Southern Quebec regions. That's why we saw extensive fire events happening all across Canada. When we look at the vapor pressure anomalies, this is taken from 1940 to 2023. We started to see an increase in atmospheric vapor pressure deficit throughout from May to October. This is like the entire growing season for most of our field crops. What the vapor pressure deficit creates is it dries out the air to near zero moisture. To explain the impact of smoke on our field crops, I am here using two scenarios. Imagine a cloudy day and a smoky day where both diffuse the sunlight. The sun is above the clouds or the smoke, but the diffused light comes through. What happens is on a cloudy day, we get lower vapor pressure deficit. That means there is enough moisture in the air. However, on a smoky day, the moisture dries out and that leads to increase in vapor pressure deficit. What it does, especially for ag crops, is like it inhibits pathogen growth because there will be buildup of calcium in the plant system. And the drier microclimate also inhibits fungal growth. On top of it, the fire also improves some of the seed germination of certain forestry and certain ag crops. That is not well tested. But there are some reports that do mention that forest fire do improve seed germination. And this smoke has hundreds of organic compounds that range in various concentrations, and they affect the plant growth and development in multiple ways. Here, smoke significantly affects our crops in the form of growth and development, mainly affecting the photosynthesis, where I can put them into two categories. If there is smoke on top of the crops, it affects it physically as well as chemically. The physical processes leads to high vapor pressure deficit that in turn leads to stomatal closure. As previously David Lee showed how dry the soil was, so the crop couldn't get moisture to keep its stomata open, and thereby it reduces growth by almost 50%. Chemically, the reactive oxygen destroys the chlorophyll molecules where the green leaves become like pale green, and the sulfur dioxide in the air also destroys electron transport chain and the enzymes that are linked with the Kelvin cycle. Lastly, the nitrous oxide also reduces the activity of major antioxidant enzymes. I'm not going into detail in the interest of time all the compounds here. So a mere 20 minutes of smoke on top of the crop can reduce the photosynthesis by 50% and hinder the growth and development of the plant. So, has this been observed in our fields? In 2018, Jay Wither wrote this article. This was the first article that kind of highlighted the importance of smoke and its impact on agriculture field crops. This was like canola growth stalled under the shroud of smoke. It came in November 2018. What Jay covered in this article was like some of the observation that were observed here in the prairies were like the smoke was the factor, and things stood still for over 10 days. This was the observation on August 15. That was like during the pod maturity phase, the pods remained green for a very long period. Were those similar observations made before? And this is from Manitoba Agriculture. In 2015, there the smoke appeared way early in the cropping season. That means when the crop was just at 8-leaf stage and bud stage, the smoke appeared. And what it led was like to a 14-day delay in transition from what it generally takes 9 days. Now it was an additional 5 days for bud to flower transition. So the growth and development and maturity was delayed. We don't have much research here in the prairies when it comes to impacts of smoke on any major field crops. However, there are now studies in California and in Australia, bushfires, where they are looking at the impact of smoke on wine industry. What the smoke does is, when the smoke appears in air, the grapes absorb some of those smoke and they get locked as glucosides when they bind with sugar. But during the grape fermentation, those molecules are broken down and that smoky flavor comes back. A wine that can sell at $60, $80, they can't sell it anymore at that price because it has off flavor, and it reduced the price of wine to just $10, $12 in Australia and in California. So in 2020 alone, an estimated anywhere between 160 to 350 tons of wineries were lost due to the smoke, and it resulted in $600 million of revenue. So what the state of California and Australia have introduced beginning next year is now farmers can insure their wineries for smoke insurance. That means depending upon the number of smoke days, just like heat days, cloud days, now we can calculate the number of smoke days. Once it reaches certain threshold, the farmers are eligible to claim insurance for the losses. So, do we know anything on similar front in canola? Not much. So, the wildfires can lead to the smoke that can be absorbed by canola leaf and pods, and it can affect the taste and aroma of the oil as well as the chemical composition. So, since I was asked to give on this topic, I bring up maybe it's time to do some research in this area, especially if these events are going to become more common, how the mechanism of compound absorption by canola happens, and testing the volatile phenolics and smoke-related compounds in the canola oil and in the seed itself, and lastly, doing some of the sensory and flavor analysis and aroma analysis when it comes to the oil. With that, thank you.
We have a little bit of time for questions. Are there any questions? Please come to the mic, or a mic runner. I think maybe come to the mic so everyone can hear the question.
Thank you very much for that presentation. I'm a PhD candidate in the field of soil chemistry at the University of Saskatchewan. I just want to be sure, I want to ask about how the smoke or the chemistry behind how the smoke affects the VDP that you were talking about.
How the smoke affects the...
Yeah, I mean, if you can provide a little bit of explanation as to how that smoke, because it appears that a cloudy day is better than smoky day for crop production. Yeah. So I'm just trying to understand the chemistry behind how the smoke affects the water vapor that supports plant growth.
Yes, definitely. The question is how the smoke affects the vapor pressure deficit and in turn affects the crop growth and development. Well, when we look at the smoke generates a lot of heat, and it, as I said, it has a cocktail of all these compounds that are from phenolics to multi-molecule bounds. when the stomata of the crop is open, what happens is due to a drying of atmosphere, the stomata starts to close down, number one. And if stomata is open, what happens is when the plant try to take CO2, all this smoke is also taken into the plant system. For example, if canola pod is photosynthesizing or the leaf is photosynthesizing, the stomata is the one through which the smoke enters, and that gives the entry for all these compounds to enter along with CO2. And they bound to certain enzymes and activities leading to the reduction in growth and development.
Yes, we have a couple of online questions here. The first one, did the CO2 enrichment due to the forest fires affect canola yields? With the CO2 enrichment is simulated by some soil crop models.
Well, we don't have any information related to studies that particularly look at like the CO2 enrichment leading to improvement in canola yields. Since it was like compounded with previous daily stock when we saw there was lack of soil moisture. So even though there was CO2, what happens is like we require water. Just having abundant CO2 doesn't help. So if the plant don't have like the water to take up from root system, the stomata are always closed, so it won't help. However, we have done some studies in wheat using elevated CO2 conditions in the presence of water, so that only CO2 environments were tested, fertilization, and we do see increase in biomass, increase in crop yield, but dilution in the crop nutrition index. Because the amount of fertilizer we are applying is the same, the crop biomass get increased and our nutritional quality goes down.
So one more question here then. Thoughts about the effect of smoke during the flowering period. Does it protect from high temperatures?
Well, will it protect from high temperatures?
Yeah, I think, do we see a temperature reduction from the smoke in the air?
I am not sure, because the air in the atmosphere dries the pollen much faster. So it may not be protecting. The pollen gets very dry. So we see negative impacts rather than protecting the flower. But there are no studies to confirm. That's something, as I said, in understanding these mechanisms, we will be interested to address some of these questions.
All right, I think that's the time.
Thank you.
Thank you, Raju. Now I'm going to welcome Acting Provincial Oilseed Specialist from the Saskatchewan Ministry, Samantha Marcino, for 2024 Year in Review.
Great, thanks everyone. As already stated, my name is Samantha Marcino, and I'm the Acting Provincial Specialist of Oilseeds Crops with the Crops and Irrigation Branch with the Ministry of Agriculture here in Saskatchewan. We'll just get right into the meat and potatoes here right off the start, but first we're going to be looking at canola production province by province, and these numbers are all from the Stats Canada estimates from September 16th. So looking first at Manitoba, their seeded acres were predicted to go down by, to increase by 7%, to settle down at that 3.3 million acres. Average yield is predicted to go down by 7%, ending up at 41 bushel to the acre compared to 44.3 the year prior. And this results in a decrease of 2% in total production, right around 3 million metric ton. In Saskatchewan, the seeded acres went down by 3%, but still sticking right around that 12 million acre mark. Average yield is up by 2%, was a prediction, so ending up at the 37.7 bushel to the acre. And production, it's actually a decrease of 0.4%. I didn't put the point in there, but still right around that 10.2 million metric ton. Looking at Alberta, the seeded acres basically remained unchanged at 6.3 million acres. Average yields, they're predicting a 2% decrease to 38.3 bushel to the acre, and production down by 2% as well to 5.4 million metric ton. Combining those all together, there is production in other parts of Canada, but majority is on the prairies. Seeded acres for Canada would have gone down by 0.4%, so really pretty steady as she goes on the acres point to 22 million acres. Average yield is down by 0.8% to 38.4 bushel to the acre, and production be down by 1.1% to 18.9 million metric ton. Some of these maps we've already seen today, but I'll just run through them quickly. This is showing the July accumulated precipitation. So this is from Agriculture and Agri-Food Canada. We know that moisture isn't the only factor to crop production, but here on the prairies it's one of the main ones and one of the ones that's completely out of our control. So this is accumulated precipitation. So we can see in July we actually aren't sitting too bad. Across the prairies there is still extreme variability from west to east, but this map really shows that some places in Manitoba received quite a bit of precipitation and in lots of cases a lot of excess precipitation. Moving to August, some of the colors actually don't change, especially in southern Saskatchewan moving into Alberta, which means there's very limited rainfall or precipitation in those months. Bit better in September. You can really tell again in Manitoba where those wet areas were. And in October, precipitation increased. Generally at this point it was too late to have any effect on canola yields. These are from the Saskatchewan crop report. So these show the top soil moisture conditions. So this isn't prairie-wide just for Saskatchewan, but it really paints a picture of what happened this year. So the top map on your left-hand corner was May 7th to May 13th. So green is good. That means adequate moisture. Blue is surplus, and orange or dark orange means that we're short or very short. So we started off the season actually looking very good, which was a welcome relief from years prior. Lots of green on that map, even a few areas that were surplus, which was a welcome change from the year before. The next map underneath it is the topsoil conditions from June 25th to July 1st. So still looking really good, lots of green and even more surplus in certain areas. So things were off to a really promising start. The next map in the middle is July 9th to July 15th. And here you can start to see some drier conditions creep in that southwestern corner, which is generally drier. So things were still looking pretty good, but those dry patches were starting to show up on the map. The map in the other top-hand corner is July 30th to August 5th. And this is when we can really see those dry topsoil conditions coming in. So very limited moisture between these two maps. And you can see already in that southwest corner, they're already very low on topsoil moisture. And this is July 30th to August 5th, so right at that canola reproductive stage when it's flowering, and we really need that moisture. And then the bottom corner, that one is August 20th to 26th. So you can see the east side of our province happened to get a little bit of rain, some better topsoil moisture conditions, but that west side continues to be drier. These maps, again, are from Agriculture and Agri-Food Canada, and it's a prediction of canola crop stress. So this is from July 2024. Green is no stress, yellow is light stress, orange is severe stress, and red is extreme stress. So in July, things were looking pretty good across most of the prairies, actually, and in our main canola growing regions. Moving to August, things changed very quickly, and again, this really follows the moisture maps, but in that southern part of Saskatchewan and into Alberta and a couple of pockets north, we're already seeing extreme stress. In September of 2024, the red is basically most of Saskatchewan, even creeping into Manitoba and a good portion of the canola growing region in Alberta. This is taken from the final crop reports that each province released. So Manitoba had variable yields across the province ranging from 25 to 65 bushel to the acre. Their 5-year average is 39 bushel to the acre. Look at Saskatchewan's from their final crop report. They're predicting a 32.7 bushel to the acre yield, so there's a bit of a discrepancy comparing this to Stats Canada. But you can really see the variation between where you are in the province. So if you look at southwest Saskatchewan, they're predicting 22 bushel to the acre. And that on that map really shows where those dry spots were predicted early in the season. And they generally are drier and do have a lower yields potential than other areas. But the northeast was coming in at 37 bushel to the acre. So if you happen to get some moisture, you're still in a fairly good yield situation. Alberta, their prediction was 33.3 bushel to the acre, so again below their Stats Canada estimate. And this one too, you can really see the variations depending on which region of the province that you're in. Other factors, and I'm not going to go into these into too much detail because James and Alireza will be going into these, but disease, blackleg seem to be very, very prevalent this year across all 3 prairie provinces. Verticillium stripe has been making more of an appearance, and I would say moving further westward and more popular over there. Sclerotinia, especially in those wetter areas, going eastern Saskatchewan and very much into Manitoba. Clubroot, which is always on the map, and aster yellows, depending on what region you're in. Insects, I'll leave that one for James because he'll give you guys a very good outlook. And then late weed flushes. On some of those maps, you can see we got moisture later in the season, which caused some weeds to come up, and we were kind of past our spraying window for some of those. So that was an issue for some producers this year. And that's all. If you guys have any questions, I'll gladly take them. Thank you.
A quick question from online here. Did you observe any abnormally small canola seeds during the harvest of 2024?
I don't know if I could make a blanket statement for that, but there was some challenging growing conditions, and with that, I do think that the seed size can get smaller.
There's another question regarding oil production in 2024, but I think that'll probably be covered later on, so you're off the hook.
So. Thank you.
Thanks, Samantha. We're going to move over to pathology. I'm going to welcome to the stage Dr. Alireza, Akhavan, provincial disease specialist with the Ministry of Saskatchewan, and he's going to give us the canola disease perspective from the prairies.
So good morning, everyone. Again, my name is Alireza Akhavan. I am the provincial plant disease specialist for Saskatchewan, and this is the Prairie report. So I am giving it to you on behalf of all the three Prairie provinces. So my co-presenters today is Michael Harding, which is my counterpart in Alberta. So my counterpart in Manitoba, David Kaminsky, has retired in October after 45 years of excellent service to the prairies, and at this time the position is vacant, but Yangmin Kim and Sonia Wilson, the oilseed specialist, helped during the surveillance this summer. Just to the interest of the time, I just made things just to the point to point out the most important diseases that happened, and perhaps won't have time to go to some details, but the reports will be posted on the website of the Western Forum on Pest Management in a week or two with details. So any details, or if you're having interest in some regional breakdown, perhaps you just need to go to Western Forum on Pest Management in a week or two, and you will see detailed reports there. So we'll start with the Sclerotinia stem rot in canola and Alberta. So again, when we talk about diseases, we need to have three different factors in our mind all together. So it's prevalence, or number of crops with disease, incidence, which is number of plants with disease, and severity, which is the portion of the plant which had disease, to actually understand if the disease was like a big factor or was a smaller. So like if there is only one single leaf in 100 fields with a disease, the prevalence is 100%. But if it is like all the plants devastated in 100 fields, again, it is 100%, so it's prevalence. So prevalence, incidence, and severity all together talk about the disease. So for Sclerotinia, Alberta reported 14% prevalence, so 14% of their fields during the survey had Sclerotinia stem rot. The incidence was close to 1%, and the severity is not collected. if you look at numbers from Alberta and compare it with Saskatchewan and Manitoba, you will see quite significant difference. This doesn't mean that Alberta has less Sclerotinia. This is how they do the survey. They do the survey after harvest. So they only look at the lower 6 to 12 inches of the stems, while in Saskatchewan and Manitoba, which is we do this similar approach. We do it at the time that is like 60% of seed change is being seen in lower pods. So this is the reason that we have the whole plants to see, and if Sclerotinia is upper canopy, we count it. But in Alberta, because they do it after harvest, they only look at the bottom 6 to 12 inches of the plant. So Saskatchewan reported 56% of the fields with Sclerotinia stem rot, 9% incidence, and severity was 0.24. And Manitoba almost similar, 57% of their fields was seen with Sclerotinia stem rot, 5% incidence, and severity was 1.7. So this is the incidence of Sclerotinia in Alberta. So we will see that they stayed at 0.9%. So they didn't have necessarily a higher amount of Sclerotinia stem rot this growing season compared to the past one. Moving to Saskatchewan, we had, again, we don't have time, so these are a really good map. They are very well aligned with whatever was given to you in terms of environment. Sclerotinia stem rot incidence is very well aligned with the environment pattern. So this year, again, we had like more moisture around, so we moved to 9% incidence from 4% incidence in 2023. So definitely in Saskatchewan, we had more Sclerotinia than last year. Moving to Manitoba, almost the same pattern as in Saskatchewan. So Manitoba incidence for Sclerotinia stem rot moved up from 1% last year to 5% this year. So today we are in Saskatchewan, so I added one regional breakdown for Saskatchewan. And when it comes to Sclerotinia prevalence, northeast region had the highest prevalence and highest incidence as well. And of course, there were quite low incidence in multiple regions, including southeast, southwest, and northwest. Moving to blackleg, which is quite a very important disease. We are looking into it during the survey. Very important disease, not only about regarding yield, but also sometimes trade. So Alberta reported blackleg in almost all their fields. 97% of their fields had blackleg. Quite very high number of incidents. 33% of plants had blackleg. And this severity 0.6, and this severity is in the scale of 0 to 5. So the reason that we have still a low severity almost relatively is because of those great work done in breeding and all those genes that they are in our plants. But blackleg was seen quite a lot last growing season. When it comes to Saskatchewan, was a little bit more concerning because we jumped. Our numbers are jumped. So from like 72% last growing season, we moved to 92% for prevalence. So 92% of the fields in Saskatchewan had blackleg. Our incidence almost doubled from 11 to 12% last year, all of a sudden to 23%. So that's quite a jump. And severity also doubled from last year, so 0.4, and this is because of the only weather. Blackleg enjoyed the weather pattern we had this year, and I don't go through details, but that was the only factor, because this is only comparison of last year versus this year. So Manitoba reported a lot, but lower than Saskatchewan and Alberta. 76% of their fields was reported with blackleg, 12% incidence, and severity of 1.2. Similar to Sclerotinia, here is also the severity scale is 0 to 5. So So moving to comparison with the historical data, for Alberta, they also saw, even though that last year they also had blackleg in almost all their fields, but in terms of incidence, they also got higher amount of plants with disease, and they moved up from 26% last year to 26% last year to 33% of the plants this year having blackleg. Moving to Saskatchewan, a graph that I was hoping I don't see it, but this is the reality now, that we had this jump from almost 11 to 12% last year to a all-time record high of 23% in terms of incidence. And again, based on the analysis we did, it is related to the temperature and moisture condition we had last growing season. Moving to Manitoba, they also had a slight increase from 10% last year to 12% this year in terms of incidence for blackleg. Again, Saskatchewan regional breakdown. So we had, so when you have 92% of fields on average, it means that all regions had a very high prevalence for blackleg. Perhaps I don't need to talk about prevalence because it was high across the province. But Northwest had higher incidence and Southwest had the lowest incidence. But it was unfortunately, it was a kind of a blackleg year for us in Saskatchewan. Moving to another enemy, Verticillium stripe. Most of the analyses are being finalized, but the final data has not been verified. For Saskatchewan, lab is still even working on doing the analysis, and work in the lab continues. But in 2 weeks, we have also those data available, but I can give you some data that is available at this time. Of course, Manitoba has their data in. They found out Verticillium this year in again, all-time record, all-time kind of high record for 60% of their fields was seen with suspect samples. So these are not like lab confirmed. This is visual assessment only. And 60% of the fields had symptoms suggesting Verticillium stripe, and 32% incidence. So again, these are the numbers that they are based on visual assessment only. But Alberta and Saskatchewan, they test all the samples at this time in lab, so this is the reason that most of the data are not available. Alberta has 2 streams for Verticillium stripe. One is general canola disease survey, and data will come soon, but I can just tell you at this time that the data still is in the final analysis stage, but it appears based on the initial data that Verticillium stripe prevalence went from about 0.5% in 2023 to over 1% in Alberta from survey. And if we add like some of the reports we received from the labs anecdotally, perhaps it is at around 2.5% in Alberta in terms of prevalence. So Saskatchewan has 19% of their field during the general canola disease survey with suspect samples, so with suspect symptoms. So symptoms that it suggest Verticillium, they are being analyzed in the lab. So over past couple of years, we kind of lost our confidence in some of the symptoms we see, like even a stripe up one side of the stem or grayish pattern, or even shattering and peeling back the epidermis if there is no microsclerotia. Many of the samples with these symptoms came back negative from the lab. So we now just kind of stick to what lab gives us as confirmation. But 19% of the fields had at least symptoms suggesting Verticillium in those fields. So Saskatchewan, in addition to general canola disease survey, since 2022, will do a post-harvest survey, which is done kind of late September, early October, and all the samples kind of being analyzed at this time. So moving quickly to clubroot, so when we have all the data from this year, we'll add it to this map. So again, we answered the main question last year, that Verticillium stripe is no longer a rare disease in Saskatchewan, and this is the data only from survey and from SAS canola program. So this doesn't include any analysis that private labs do. So it's quite common. So moving quickly through clubroot, perhaps Alberta has the notes. 7% of their fields during the general canola disease survey was found with clubroot, incidence 0.7% and severity 0.1. So again, frequent finding of clubroot. Manitoba, no new symptomatic cases through the survey. 2 were reported out of the survey and 1 additional field through the DNA testing. 40 fields are sampled for soil, and the soil analysis are being done in the lab. Since June 24, 2024, last growing season, clubroot is no longer a regulated pest in Saskatchewan, but for 1 year we follow the same tradition in terms of releasing our data, and we wait until the crop production show week to release the map, but just I can say that new clubroot occurrence in Saskatchewan appear to be very limited as well. So moving quickly to aster yellows and Alternaria black spot. Again, not much time to go to details, but aster yellows is becoming a more important disease last year and this year. So 25% of our fields had aster yellows if we're only looking at those 100 plants we assess in each field. But if we add fields with plants out of that 100 plants that we assessed, then 71% of our fields had aster yellows. Alternaria, 69% of fields in Saskatchewan was found with Alternaria, 38% with Manitoba. So it was like the quickest update I ever gave for diseases for prairie-wide. So sorry if I took a couple of minutes extra.
That's all right. It was a big ask to get through all of that information in 10 minutes. Unfortunately, we don't have any time for questions, but Alireza's around all day. Find him at lunch. Next, we're going to move on to entomology. Dr. Jim Tansey, Provincial Insect and Pest Management Specialist from the Ministry, is going to give us the update of insects in canola in 2024.
Hi, everyone. Rather than going into too much detail, I'll let you just take a look at the contributors to this. Thanks, everyone, for their information. We'll talk primarily about flea beetles. Of course, flea beetles are the major springtime pest of seedling canola. We got 2 major pest species in addition to a native species. We won't talk about the native species. We'll just talk about the naturalized Europeans. They have different climate preferences. So crucifer flea beetle, which historically has been the dominant pest species, likes things hot and dry. And of course, as ebb and flow happens with weather conditions, it's going to influence their populations as well. Striped flea beetle likes things a little bit cooler and wetter, so it tends to be historically more important in northern regions, and that was the case this year as well. There's also differences that have been demonstrated in their tolerance to specific insecticides, most notably the group 4As, the neonicotinoids. So it's hard to throw a rock without hitting a neonic when canola is concerned. So most canola is treated with a neonicotinoid insecticide. So those 2 factors can combine to influence species prevalence. And what we were seeing for several years was this shift in species dominance, with striped flea beetle working its way all the way down to the Dakotas and becoming the dominant species there. They seem to be moving further north. So with that, looking at the populations from this past year and some of the incidents in Alberta, spring crucifer flea beetle was required, control overspray was required in the southeast, and some heavy populations primarily of striped in the north. Similar story for Saskatchewan. We did have some hot spots for crucifer in the Kindersley area. The primary damage was in the northeast and the northwest, and this was associated primarily with striped. A bit of a plus note, the new product Buteo Start seems to be very efficacious for both species, which is good news. So significant populations in Saskatchewan, at least, of crucifer flea beetles in the fall. connecting fall populations to spring populations is not a straight line from A to B. So they're excellent flyers. We can find them overwintering miles from potential host plants. So these little beasts are actually excellent flyers. In Manitoba, widespread accounts of spraying, some incidents of multiple sprays. We didn't get a lot of reports of that, except in the Spiritwood area in Saskatchewan, and some reports of reseeding. So cool wet weather prolonged seeding development, as mentioned in a few of the presentations already. We had cool wet weather in the spring. This has a profound effect, of course, on stand establishment and a really heavy effect on insects. Insects are, of course, ectotherms. Everything about them is dictated by temperature. So if things are cool and wet, that's going to slow them down. So unfortunately, it slowed down seedling development as well. So you could get some incidents. It was important for flea beetles and some other pests, but more important for vertebrate pests, and we'll talk about that briefly in a bit. John Gavlosky and I submitted samples to Boyd Morey at the University of Alberta to look for Group 3 insecticide resistance. Of course, if there is an overspray required, that's probably going to be deltamethrin, or something, a closely related substance. We wanted to find out what was happening, if anything, with resistance. Happily not detected at this point. What is a little concerning, though, is there's some initial, Boyd has developed some data in his lab that seems to indicate the crucifer flea beetle is becoming less sensitive, at least in the samples that he has, to group 4A insecticides. So that is the neonics. So some less sensitive to that class chemistry than from the work that I did in 07-08. Diamondback moth, migratory adults. I had an asterisk on this because there was some speculation as to whether they were overwintering on the prairies. The conventional wisdom is that less than 1% overwinter. They typically migrate from southern ranges, so that is winter crops in Texas and Florida, northern Mexico, sometimes a little bit further west, but for the most part in that southeast U.S. They're going to take flight when they're cold crop hosts, and you can see that there's a cold crop here, cabbage that's been eaten really well by diamondback moth. They take flight when those are harvested. They fly at about 300 to 500 meters. Typically, they're following warm winds, and although they can get as high as 4 kilometers in the air. So it's going to be a one-time migratory event, typically. We had indication that they were overwintering here, or what looked like they were overwintering here. Really fresh, nice-looking adults were showing up in Alberta, Saskatchewan, Manitoba. And this could have an influence on how we approach this animal for control. So we put it to some collaborators. I don't see Tyler in the room here, but he reached out to one of his collaborators, whose name I don't recall. Tyler, do you mind just hollering it out? Thank you. So they did deuterium analysis. There are 2 stable isotopes of hydrogen. So one is protium, one is deuterium. They occur in stable ratios in different parts of the world. So that gets incorporated into water, water gets incorporated into plants, herbivores eat plants, and they'll have a signal based on where they come from. So based on this excellent work, I can't take credit for any of it, it looks like our diamondback populations are in fact American. So if you feel the need to salute them, yeah. There you go. So a bit of a good news story as far as that goes. So we do continue to monitor for this, and we have sentry sites in all 3 provinces. We didn't see significant issues in either 3 provinces as far as insecticide applications going down. We have had recent incidents of Group 3 resistance in the Dakotas, and it is something that we continue to watch for. So we'll keep you posted if we do happen to see Group 3 resistance. But happily, not much in the way of spraying. Please ignore all the red in the Peace Country. Those traps were out for many weeks longer than the other ones, so I consider those ones to be artificially high, and we're going to attenuate this map. But you can see overall populations were relatively low with a few hotspots in Manitoba. Bertha armyworm, happily numbers remain low, and that's pretty much full stop. We did have some reports of spraying for, similar looking animals, particularly clover cutworm, but Barthet doesn't seem to be that numerous at this time. We do continue to monitor for it. It can be a devastating pest when it occurs in large numbers, so we will continue to monitor for it. So 270 sites in Alberta, 292 in Saskatchewan, 82 in Manitoba. Catches were moderate. But looking at the overall trend, this is the map of Saskatchewan. Unfortunately, we don't have a prairie-wide map of the catches, but you can see we got some warm spots. We catch them with synthetic sex pheromone traps. So that is, as for a male, we take what he thinks is going to be a very good day and turn it into a very bad day, and he dies in there, and we count him. It's not how we wanted that day to go. But you can see the populations are still relatively low. I mean, they can ramp up relatively quickly. So this is something we're going to keep an eye out for. One really notable thing with the cool, wet spring is emergence was delayed at least 2 weeks. So normally we would see, about a mid-July peak in emergence. It was nearly into August by the time we were seeing peak emergence of this. So once again, ectotherms, everything's about temperature with these guys. Cutworms. These are larvae of multiple species, and we have literally dozens of different species of noctuids that can be economically important. Typically on the prairies, it's going to be red-backed and pale western, although dingy, which is actually a species complex of 3 different Feltsias, can be really important in eastern Saskatchewan and well into Manitoba. For the most part, if you've got cutworms, there's a decent chance you're looking at red-backed cutworm. So some issues in Alberta, primarily in central and northern regions, with some spraying and some reseeding. Saskatchewan, virtually no reports of significant damage, at least that crossed my desk. Manitoba, there was some spraying in several regions and reseeding in the southwest. Oh, interestingly enough, that field actually had a diamide seed treatment, so that is, I don't remember if it was Lumiderm or Fortenza, but a group 28, which should smoke Lepidoptera, and that field needed to be reseeded. Lygus bugs, for those of you not aware, the thresholds have been revisited. So 2 to 3 per sweep at late flower to early pod, full stop. So once the crop matures past that point, its susceptibility to lygus feeding is relatively low. So not much to worry about. That's the time to control them. For Alberta, there were economic numbers and some spraying. Saskatchewan, moderate populations, but the vast majority of these occurred far too late to warrant spraying. Manitoba, some spraying in the eastern and interlake regions, and high populations in northwest and central. Some of these were late as well. Cabbage seed pod weevil, this is an invasive species and one that we continue to monitor enthusiastically in Alberta and Saskatchewan. And now John is starting to take these up now that they've established in Saskatchewan. I'll jump to the chase for Manitoba. The numbers remain low, but obviously we're going to keep an eye out for that one. We did have a significant hotspot in Saskatchewan. We do not monitor a number of sites, and I'll just jump to the map there. So the Swift Current area, we had economic populations, many of which required chemical control. Some honorable mention, aphids, green peach aphid, late season, canola flower midge, restricted to northern regions, some reports of crickets, some reports of grasshoppers. Most grasshopper populations were greatly delayed by the cool conditions. And if I have one last non-vertebrate, or vertebrate, non-vertebrate, yeah. Richardson's ground squirrel, lots of reports, especially in Saskatchewan, of gophers eating the heck out of canola crops. And this is a photo that I took in the southwest near Swift Current, and you can see that is to the horizon, has been cleared off by gophers. This particular grower put down $30,000 worth of gopher control products. So that's one grower. He's a big grower, but... significant problems in western and southern Saskatchewan. This is the take-home message. Control them when they first emerge. Before green up, there are products registered for their control, or if you favor a blunderbuss, then go that route. You'll notice too, they're not active for the full year. It's the reproductive females that you want to target. We did some testing in 2022 and 23, and we found that the zinc phosphide products, burrow oatbait and zinc ZP rodent oatbait ag, were as efficacious as strychnine. and numerically better than some of the anticoagulants that are available. However, all of these are efficacious products. So this is my last slide here. So again, apply baits before green up as early as February. If you see bald eagles active in a field, that means they're hunting gophers. So that's a good sign that the males have started to come up as the eagles are moving through. Zinc phosphide, that's my recommendation. Very little in the way of residues. Anticoagulants are heavy, can be heavy with residues and represent a threat to non-target species. And vitamin K is, of course, the anticoagulants are vitamin K interferers. Pardon me? And my slides are jumping around. Yeah, vitamin K is the antidote that's present in green plants. Predator tolerance, so that is predator the full suite of predators. Be tolerant of your badgers and your coyotes. They do a number. And the Saskatchewan Gopher Control Program for Saskatchewan residents. You can get a rebate on the construction of raptor platforms and chemical control. So that is a 50% rebate. There's no cap on chemical control. But for raptor platforms, I think you qualify for about $250 per unit. So with that, thank you.
We once again don't have time for questions, but find Jim at the lunch break. I'm sure he's around all day. Our next speaker is Véronique. Which one? There we go. Our next speaker is Véronique she is the manager of the Grains Research Laboratory at the Canadian Grain Commission, and she's here to discuss the quality of the 2024 canola harvest.
Okay. Just a recap of the environment that didn't talk about everybody. It was really wet early and cold, and then it became hot with no water. And one of the issues for me actually was some of the water in September. So this is I look at the seeding and I look at the harvest because how the seeding is processed when it's starting. It's going to give an idea about the quality. So what actually was interesting this year is Manitoba, because of all the water we had, was about 2 weeks later in the seeding compared to last year. So technically, Manitoba should be 2 weeks later compared to last year in the harvesting. And the fact that it's not, meaning that the heat and the dry condition actually push the crop development faster than normal, and that's going to have an effect on the quality. The other thing which is important when you look at the harvest, or what is important for me when I look at the harvest progress, is actually when there is a stop. Because the line is not going smooth, and every time there's a stop, that means there is rain. Because the producer only stop for rain. They don't stop for coffee or breaks. They stop for rain. So every stop there is a rain. There was the first stop in Alberta, and then after that, you have a second one, and then there was a big stop in Manitoba and Saskatchewan. So which means that when you have moisture on mature seed, you're going to have sprouting. So that means that there's a high probability when I look at the graph like that, there's going to be sprouting in most of the canola this year. Okay, number of samples that we achieved. We lowered than last year. We still lowered so far because of the postal strike. In the last couple of weeks, we got 2 samples of canola that somebody purulated to us, and 2 samples of flax that somebody dropped at one of the sites and we got. So I'm not sure if we're going to get more samples because people might forget that they got the envelope and then won't put them in the mail if the mail is coming back, or I'm not sure if suddenly in January I'm going to end up with 600 samples. So this is a big unknown, and that's also affecting the data, because if you don't have a good representation of the sampling and you might have not a good idea about the quality. So 90% of number 1 this year, which is pretty good. And I will go back to the defect. But normally when you have canola, the main defect is green seed. Well, this year, green seed is not an issue. This year, actually, the issue is sprouting because of the water that we had. And the other issue is oxidized seed. And the reason why is because the plant was stressed. There was a lot of water. So the plant started to be stressed a bit because there was too much water. And then there was not enough water. And then the plant was stressed again because there was not enough water. So there is some seed abortion, and those seeds end up being oxidized. So that's the two defects this year. And when I was looking at the representation when you have the percent of number 1 and number 2 and number 3, and this is only the percent of number 1. So it gives you an idea about where the defects are and the south and some of the area. That's where the lack of water and the heat were the more prevalent. This is where you have some more of the defect. So oil content, it's not supposed to be a surprise for everybody, much lower this year than last year, about 1%. And so conditions were different this year than last year. So last year there was some very cool night. And during the cool night, the crop had time to recover. That was not the case this year. There was almost no cool night. And so there is a defect, lower oil content. And that's everywhere. So when I look at the average, and now I'm going to have all the slides will be about the same. I have the 5% average, the 10% average, and then the last data for the 20 years. So lower than last year. The good news is it's not as bad as what it was in 2021. Because 2021 was the lowest oil content we had because of drought. And even if we were in very similar condition, we still have a better oil content because probably more new variety have been developed since, and those new variety on the market have been developed with the last couple of years of heat and drought, and there may be better genetics over there. So when you have lower oil, you're going to have higher protein. Well, that's no news. This is what you have, and them thing. Just one of the comments that I have between when I look at oil and protein. Like the 5-year and the 10-year average, especially the 5-year average, is not really what I consider my long-term average, because my long-term average will be more from 2006 to 2020. This is what I was considering my long-term average. But because 2021 was so low, and that's such a big influence of the data, that's the reason why your 10 years is a bit, different than what I consider the average. But that's for everywhere. Milk protein, which is very interesting for the people looking in the feed industry, it's a bit higher, which is also pretty good for the people, and that's because we had higher protein content in the seed. So glucosinolate is lower this year than the previous year, which is kind of a bit of a surprise because we know that when there is drought, there is an increase in the glucosinolate, but there was a decrease this year compared to the last couple of years. And the reason why is because those varieties that were high in glucosinolate are no longer in the system. So this is not so much about an environmental effect. There is this year a genetic effect on some of the data, and you see it in the glucosinolate. Milk glucosinolate is pretty good. So, everybody will be happy about that. Seed chlorophyll, this is no genetics. This is purely environmental. No frost in September, almost no frost in October. So that's the reason why you have low chlorophyll. That's not a genetic factor. This is environmental. And as long as we will have no frost in September, no frost in October, we will have low chlorophyll. So which is pretty good for the crusher. Oleic. So that's when it started to be quite interesting, actually, for me. Because normally, when you have lower oil, because hot and dry, you're going to have higher oleic acid. And this year, we had lower oleic acid than last year, which, in a way, didn't really make sense. And if I look, same thing with alpha-linolenic acid. Alpha-linolenic acid follow the oil content. So if you have lower oil content because of the weather, you should have lower alpha-linolenic acid. And again, this year, this is kind of weird. For me, it was much higher than last year, about 1%, which is really good. Don't trust me. You know, like I like high linolenic acid. And then I look at C18-2. And C18-2 this year is also higher than last year, which kind of was thinking, well, this is really weird. And I was trying to understand why. And then same thing. The only things that actually following the normal pattern in the saturate, which is a bit higher than last year, but because there is the pressure of the breeding, you don't see so much of the difference, but that's the only things in the fatty acid composition that actually following the weather pattern, hotter and warmer than last year. And the iodine, because the iodine value is looking at alpha-linolenic acid in C18-2, linoleic acid, then you have higher iodine value than last year, which is, again, doesn't make sense. So why didn't make sense? I'll look at the variety. So the Grain Commission is actually publishing talking to the Alberta, Saskatchewan, and Manitoba government, and they get the insured acres. And then every year I compare my variety into the insured acres. And then this year, actually, there is a shift in the variety. And what I saw is there is about 10% more in my variety distribution, 10% more variety that has higher alpha-linolenic content compared to last year. And I think that's the reason why it's really a genetic effect this year and not so much an environmental effect that I see in my fatty acid composition. The big issue that I have is I have 27% of the people that don't know which variety they're growing when they send the envelope to the Grain Commission. So for me, it's kind of a bit an issue, and that may be the reason why my variety distribution is not exactly what I see in the insured acres. Anyway, just to recap, when you look at the data, and especially when you look at the chlorophyll, you can see that actually chlorophyll is not an issue, and green seed is not the demand factor. So what we had the sprouted seed. And 20 years ago, I did a project on sprouted seed and showed actually the main difference between the seed on one and the sun seed was oil content. There was lower oil content in the germinated seed compared to the other one, which is normal because the seed are using the oil for energy. At the time, there was not a big difference on the free fatty acid because for a crusher, what is important is the free fatty acid content. But at the time when I did the project, there was not much storage in farm. So the problem that we're going to probably have this year is those seeds, because they're broken, are not going to be able to store very long. Because they're broken, they're in contact with the oxygen, and you're going to have oxidation and free fatty acid that are going to happen in those seeds. So we started the project when we're asking producer to send us samples. So please, if at one point you get a call, send us some samples because this is for a research project. And the only things that we saw, this is not a really good photo, okay, because I didn't find photo of oxidized seed. It's those kind of browny seed. And those browny seed actually already are oxidation. So they're already high in free fatty acid and they're high in peroxide. So those brown seeds also are not going to store. And so again, we have a research project when we're looking at what they are now, the quality they are, and the quality they're going to have after storage. Reports are published, weekly. There won't be any update for the last couple of months until we have more samples. So, if you got the old one, no need to look after. And then this is all the people that were involved into this presentation and doing the work behind. Thank you. And I don't think there will be time for question.
Thanks, Véronique. Our next speaker is Jemanesh. Jemanesh is a colleague of mine at the Canola Council. She is the coordinator of the WCCRCC trials, and she's going to give us a talk on canola performance testing and variety recommendations in Western Canada.
Okay, thank you, Ian, and hello, everyone. In my upcoming 10 minutes, I would like to address the WCCRRC committee itself, the requirements for a recommendation, and some highlights from the 2024 trials, because I include the two topics in case there are new attendees which we don't know about, don't know about WCCRRC and what it's doing. WCCRRC stands for Western Canada Canola and Rapeseed Recommending Committee. It recommends canola and rapeseed cultivars based on agronomic performance, disease resistance, and also quality standards. The two traits, which is agronomic performance and disease resistance, is mostly for information purpose and to communicate with growers, whereas quality standards are the main factors for merit calculation and for recommendation by the committee. WCCRRC is administered by Canola Council of Canada and governed by Board of Directors. The Board of Directors represents all sectors of the value chain, including canola producers, canola seed exporters, crushers, Canadian Grain Commission, animal nutritionists, and also the Canadian Food Inspection Agency Variety Registration Office. Those all in black are voting members, whereas the CFIA Variety Registration Office is an observer, non-voting member. Some of the roles of WCCRRC includes secure, store, and distribute check seed for both first-year and second-year trials that are conducted across the prairies, and also conduct black leg testing across 8 locations in Manitoba, Saskatchewan, and Alberta, and also perform spot inspections for the trials that are conducted in Western Canada, and also coordinate quality testing with Canadian Grain Commission for verification entries that are at the level of second-year testing, and data integration and recommendation for registration. Besides the main committee, there are also subcommittees, such as the Specialty and Contract Registration Committee, which reviews high-risk rapeseed as well as special quality canola cultivars, and the WCC Plant Pathology Subcommittee, which sets guidelines for black leg testing, as well as review and approve all the black leg data that are collected from WCC black leg trials that are conducted across Western Canada, and the Quality Subcommittee, which do the same for the quality aspect, which is especially starting from this year. There is a very large number of people are joining this committee and very active and conduct so many meetings and discuss many quality aspects and standards. And there are temporary committees as needed. With this, I'll pass to the requirements for recommendation. The requirements depend on the type of recommendation. For example, for interim recommendation, WCCRRC requires a minimum of data from 12 environments for yield and quality, and at least a minimum of 1 year data for blackleg. And also, developers need to disclose the herbicide-tolerant nature for their candidates, including the trait as well as the construct. For full recommendation, it is a requirement for data from 12 environments for agronomy and for yield and maturity, and also for quality 7 environments data and a minimum of 3 blackleg data that are collected for 2 or more years, and the same for the herbicide tolerant. The other category is contract registration, which these days we have so many requests, and there are some small starting companies also want to use this opportunity. For contract registration, data and information must be submitted to WCCRCC before February 1st. And then the Specialty and Contract Registration Committee will review and evaluate the harm, the level of the harm, if that candidate will grow to the conventional canola crop, as well as the committee checks if the trial is conducted following the WCCRRC procedure, as well as it is mandatory also to submit the quality data, which is indicating the quality feature of that candidate, along with uric acid and glucosinate data. And it is also important to submit a black leg data for any candidate that is with the special and contract registration as well. And the applicant also must demonstrate how the cultivar is utilized in a vertically integrated production and marketing process, so that it will not be entered to the traditional market. In terms of cost, all developers need to pay entry fee based on their entries for verification. That means entries for quality testing in fall should be in the black leg testing in the summer. So it is, if a company has, for example, 10 entries for black leg, that's how the entry fee is calculated. For example, for 2024, it was $4,500 per entry, but it's not be the same. For example, next year, if we have more number of entries, the entry cost will be lower. And if it is less number of entries, it is will be higher, because this cost has to cover all the expenses of WCCRRC, and there is an additional fee of $100 for entries that are passed for verification from the first year trials. My last one is the 2024 WCCRRC trials highlights. This year we have received 94 entries for verification, out of which we have seen on the left the herbicide tolerant nature of the candidates, and 50% of the candidates this year are with Liberty. And here are the 2024 first-year trials that are conducted across Western Canada. We had 1,296 trials on 112 locations, which most of them are in Saskatchewan and also in the mid-season production areas. And the second one is the 2024. For second-year trials, we have 296 trials on 111 locations, which similarly, most of them are in Saskatchewan and in the mid-season zone. 40 of the black leg trials that are conducted by WCCRRC at 8 locations in Western Canada. The last category with specialty and contract registration, there were 8 trials at 6 locations. Which one is for black leg. Out of these 1,600 trials, 204 trials were canceled due to biotic and abiotic factors and weather factors that the previous presenters are presented. But this number doesn't include trials that are canceled due to high CV. With this, I would like to wind up my presentation. Thank you.
We'll do one question. Okay. We have time for one question.
Yeah, there's one question that's came up a couple of times throughout this this session, and that's on seed size. Do you have any indication from your trials? Was there any impact on seed size this year from some of the conditions? And maybe, Véronique, if you have anything to add, we could get your point of view as well.
Sorry, seed size for quality or?
I think so, yeah.
Yeah, before we request 80 gram per sample, but this year it is the minimum requirement is 50 gram.
Yeah, we noticed some small seed, and we're going to start a project also where we're kind of looking at the seeds to see if we getting more small seed than normal this year. So we're looking at it. I'm not sure if we're going to have the answer yet, but we're looking at it.
All right. Yeah. Thank you, Jemanesh.
Okay, so for our second speaker, I would like to invite Ray Daniels up to the podium. So Ray is a Sustainability Market Development Manager at BASF. And he joins us from, was it Atlanta, Georgia? So he's come to have fun in the Canadian winter. So I will hand it over to you.
Thank you. Thank you so much. I will say Saskatoon is nice. It's not quite as cold as, Winnipeg in January, but like Neil Young says, we're not at the corner of Portage, Maine, and it's not 40 below. So I'll take that as a win. Thank you for having me. Thank you, Mark. It's a pleasure on behalf of BASF to be up here talking about sustainability, carbon intensity, fuels. It's something we're very excited about as well. And I want to talk a little bit about that. Again, my name is Ray Daniels, and my role is focused on developing programs, initiatives to help make the most out of sustainable environmental outcomes on farm. All right, so in the case of biofuels, that would be carbon intensity, but other projects. I work across the US and Canada, across all different cropping systems, focused on oil seeds and so forth for fuels, but also in cotton production in the southern US. So I have a pretty wide range of different topics here, but we'll focus on canola today. So a question I get asked often is the word sustainability is quite loose. It's used in so many different places. And what does it mean to BASF? That's a question I'm sure you're probably asking. And so you know who we are as a leader. We're a leader in the world of seeds and traits, crop protection and agriculture, seed treatments, even digital farming. But for us, our question about where does sustainability play into our organization is quite important, because we are keen to find ways to help farmers maximize on sustainable agriculture and improve overall environmental outcomes. And so for us, our position on sustainability and sustainable agriculture boils down to two things. First, we envision a world where what's right for the planet is balanced with what's right for the farmer's business, trying to balance the equation between positive environmental outcomes and viable economic viability for agriculture. How we deliver this, or how we participate in this space, is by providing solutions real solutions that help enable farmers to create positive outcomes with sustainable agriculture. And that's really supporting them in and along this journey. What do we see as sustainable agriculture? I mean, how do we define this? Boils down to really a couple things, but it combines the agronomic practices that regenerate soil health and or reduce greenhouse gas emissions, while also helping maximize yield and profitability for the long term. And in a sense, sustainability. It's doing, but making the most of what we have and still watching what we're doing in the process. And so for us, there's a lot of benefits we see for all stakeholders. First, for the farmers, it creates greater crop resilience in weather extremes, as we saw from some of the charts earlier, the different weather extremes we've seen, whether it's drought or rain. Additional income opportunities. We are in a cycle now where farm incomes are continuing to go lower. I think I saw this morning a headline in the U.S. that the U.S. farm on-farm income had dropped another 6%. And so we're beginning to see that there's sustainability can play a role in bolstering on-farm incomes. What can it do for the land, though? I mean, we talk about economics, but what can it do for the land? Well, one, sustainability helps reduce erosion, helps improve greater water holding capacity, and that's very critical in places like southern Alberta, southern Saskatchewan, as we continue to pull on the aquifer and have to pump more water. And then also rebuilding soil organic matter. And finally, what does it do for the planet? I mean, obviously, we talk about CO2 captured in the soil and reduced greenhouse gases. So in short, sustainable agriculture has an incredible opportunity for us, but also for the rest of the world. But that being said, what is BASF doing in this space, right? I get that question a lot. And we are doing actually a lot of different things, but it boils down into really 4 key categories, 3 of which are more external and 1 of which is an internal focus. First off, it's about pathways, and that's enabling farmers to maximize and monetize on sustainable farming outcomes. Building platforms that connect them to these markets, just as my panelist Jason mentioned before, that are available both here and in Canada in the future and in the US as currently. We're also investing into technology, and looking at not just how digital can help, but also how do our seeds and traits and genetics help improve outcomes? How do our crop protection products help reduce inputs and maximize efficiency? And looking across all of our different, our future R&D pipeline, as well as what is existing in our market today and how does that contribute to sustainable agriculture? So whether it's doing trials, and I can talk more about that later, but trials where we measure carbon intensity at various cropping systems or whatnot or not, the goal is to try to demonstrate and find ways to use that technology to improve those outcomes. And then thirdly, it's advocacy. We mentioned policy is so critical to so much of what we do, but advocating on behalf of smart policy for agriculture, both here in Ottawa and in DC. Currently, our team this week is actually spending time in Ottawa for a conference and meeting with a lot of different policymakers and future policymakers on these topics to try to educate on what these sustainability and other agricultural topics mean for an incoming government. We're doing the same in DC right now, but these are really critical because sustainability is in so many conversations at the heart of it. And then finally, it's a lot about transformation. And there's a saying that we like to walk the talk. It's hard for us to ask farmers and ask of the agriculture community to do more with less, to be sustainable, to think about sustainability, to maybe make changes in the way they run their operation if we're not willing to do it ourselves. And that is something we are tackling head on as a company, as a global company, as also as an agricultural company. We're focused on initiatives right now to reduce our scope 1 and 2 emissions, as well as identifying ways to further reduce scope 3 emissions. That's not an easy task, but we believe totally if we're going to, that's in our best interest and everybody's best interest for the future. It's what will make us in the long term a transformative organization. So these are the 4 categories of which we engage into. So that being said, I want to first talk about the subject of carbon intensity that came up earlier. So how do we view this topic, especially in the sense of biofuels? And I'll tell you, a couple of years ago, carbon intensity to me was a new phrase. I was thinking carbon sequestration, carbon holding capacity, but in carbon intensity is, I would say, becoming even more important in how we talk about the inputs that go into the value chain, whether it be biofuels or food inputs. It's not always so much about can we offset carbon, but what can we simply reduce the intensity of that production or measure that? And so for us, we look at this as an equation, all right? On the first, in the numerator spot, it's about reducing tons of CO2 equivalents, right? So you can, by sequestering in the soil and improving the soil holding capacity for carbon. And that can be through things like no-till and cover crop implementation. Also, but for us in Canada, the biggest area, because I would say as a US participant, that Canadian agriculture is so far ahead in terms of sustainability. Tillage and meltwater management is something in Canada we've been, took down the house. This opportunity is in nitrous oxide reductions. Okay, here we go. Lights came back on. And that is really an area where I think a lot of us are beginning to focus. I'm looking forward to some of the sessions tomorrow to hear more about that. But the other half of carbon intensity is not just reducing the emissions, right? We have to do that, is of actually improving upon the yield, right? If we take absolute emissions down by 30% when we reduce fertilizer, when the impact on yield is negative, right? So what is that going to do? How does yield play into this factor? And that's where we look at our particular, our wheelhouse of whether it be digital or using high yielding hybrids like InVigor, or even helping protect yield with fungicides like Cotigra. But all these play together and help lower carbon intensity when you're able to reduce emissions and boost yield. The tons of CO2 equivalent per bushel goes down. And so if there's anything you can remember about carbon intensity, and I'm happy to take questions on that too, is that it's about both yield improvement and greenhouse gas reductions. So it's not simply about yield, it's about both. And the second piece of that is it doesn't always necessarily equate to an absolute greenhouse gas reduction. I want to be very frank on that topic, is that it's about maximizing efficiency, and by virtue of that, maximizing not just the efficiency of how our operation works, but the efficiency of the ecosystem we pull from to actually create that, and doing so in a way that's sustainable. How do we turn this into something that's a benefit for agriculture is an area that we're all very keenly interested in, but one that I'm spending a lot of time in these days. And that's looking at how do we take the value of low carbon intensity crops and connect that into an ecosystem in the value chain to create value there. In biofuels, this is a huge opportunity eventually for Canadian landscape, but in the US right now, we've launched a program. This is an example of something that we're doing for ethanol, which is driven by policy, tax credits and incentives guaranteed through the Inflation Reduction Act and 45Z, the rules set there. We're waiting to hear more on that, but this is an area where we're trying to connect the farmers connect the dots in the value chain. So what we've done in this program is, one, we've given farmers a tool in our Xervio Field Manager platform to be able to calculate carbon intensity based on what they're doing. We've actually been able to give retail agronomists the ability to make recommendations on how to further reduce carbon intensity, right, of production of canola, or in this case, it's corn ethanol, but in our case, it would be canola eventually. But on the other side of that, it's all valuable, but then it's how do we connect the dots to the refining space? And that's where we're working with biorefineries on providing a supply shed view of grain CI with verification tracking. And that's a new platform we launched that connects them called Xervio Bioenergy. And that's something that, again, we've already had several commitments in the US, several groups that have lined up to work with us once we see the legislation or the rule set finally come out. But the point being is this is going to create an opportunity for farmers, for those in the value chain, to really participate in or monetize the benefits of their sustainable production. And so lastly, I'd say, I want to touch on advocacy one more time, because I can't go without saying how important this is. Each day we spend time in DC or Ottawa talking to policymakers to try to, or to learn more about what changes are coming and how to put agriculture out in the best light. But we also have a resource we've launched 2 years ago called the Center for Sustainable Agriculture, which is a physical location sitting on our Research Triangle Park headquarters in North Carolina, that really focuses on educating a broader audience. And this is our mission statement, to educate a broad audience in support of farmers and the important role that sustainable agriculture plays in providing food, fuel, feed, and fiber to the world. And what we've done in this space has been able to engage with, again, policymakers and others. We've had quite a few panel discussions and events hosted there on this topic and others, but also members of the public, educators and so forth to really demonstrate what is sustainable agriculture and and give eye-opening experiences to those who've really never have had the chance to touch our world. And in 2024, we've had quite a few successes of that. Now, looking forward into 2025, because we're always looking at changing and improving and adding to it, we want to take the center from not just a place where we've done a physical location or area where we've done events or a neat place to do events, but really take the Center for Sustainable Ag and lift it up to be a thought leadership center. And that's where we'll be looking into conducting research and working with people in industry, academia, and government and elsewhere to try to tackle some of these bigger questions and to also provide, research and information to the public about the importance and the benefits of sustainable agriculture. And that's one of the things that'll also be that's not just for the US, that's also for Canada. So that's more broadly. Finally, in closing, I want to give a look into the future, because the question is, today we're talking about biofuels. I mean, 2 years ago, we were talking about carbon farming. I mean, I often get asked, hey, what are we going to talk about 2 years from now? And I like to say that it's a building process. We're learning and we're continuing to build our capacities in this space. And in the future, though, I give you an example is I think agriculture has so much potential not from just decarbonizing one sector, but from improving outcomes across all sectors. And to give you an example is of really creating a circular economy. And the example I'll give you is this is a graphic that has corn in it, but you can take that out and we can put canola seed right there as well, is thinking about just starting with generating low carbon intensity feedstocks, growing them on farm, producing them, then putting it and selling that into the value chain for fuel production, which obviously leads to biofuel, oil, could be carbon, CO2. But what's left over at the end of the day? It's not just about the oil. I like the comment earlier about food and fuel, and that might come up in the panel. But what is that? What's left over with that? Well, then in this case, we have meal. In the case of corn, you got low carbon intensity distillers grain. It can move on to a low carbon intensity cattle operation, of which this is of growing importance to quite a few stakeholders and restaurants here in US and Canada and abroad. And then from there, right, we've terminated our waste and what we're doing with it. But beyond that manure can go into a waste step biodigester, turns into renewable natural gas and feeds the cycle all over again. So the point I'm getting at when you think about agriculture, this is just one piece of a bigger opportunity that we all have, all of our customers and our farmers and others. And I got to say, though, in closing, is that what's unique is we actually have the tools today, not as much understanding, but we have the tools today to be able to bring this to life. It's not a question of how. Simply, it's a question of when. And I just like to say it's a question of when. It's when, as an industry, do we take that decision and move forward with policy, with participation in these types of markets to create a better future for agriculture, but also for the planet and for society as a whole. So with that, I want to thank you so much and look forward to questions on the panel.